Okay, I'll give everybody another minute. Meanwhile, you can open up your guided notes, jam out a little bit, check out the updates on the election. All right, welcome back to the best class of the day. Hopefully you guys are doing well, and hopefully you enjoyed the 5 days off from seeing me, but I'm excited to see you guys again and ready to roll because we have to finish up these topics over here so we can move on forward. We are going to have a benchmark. What benchmark is going to be probably next Friday, Thursday, maybe next Monday. We'll see on that. ISU Mila. Try to get here another minute or two earlier, please, for next time. So we will have a benchmark number 1, and it's going to be on everything from obviously beginning of the year to where we end up at that point. Hey, Alex, try to get here a little earlier too. And Philip, welcome. Try to get here a little earlier as well. Frank's not here too. Perfect, full roster. Hey, Frank, try to get here a little sooner, please. All right, so anyways, on that note, yesterday was election day, and we don't have a president yet. Here's a little snapshot of the United States. If it's a nice bold red, then that was already claimed. If it is a bold blue, it's already claimed by the party as well. So like the faded out colors, they're still up in the air. There's not a given party that the state is given to. If you don't know anything about politics yet, the blues are the Democratic Party. So Northeast, Joe Biden's the Democrat party, the bid. And a lot of this is Democrat controlled. So a lot of the East Coast is owned by Joe Biden and party. The reds are the Republican Party, and you can see that Trump has a lot of Central America. West Coast, you can see Joe Biden claimed a lot of those as well. So here's how it works out. It's not every vote. It's per state. Every state has electoral votes. So Florida, for instance, has 29 votes. And whoever wins that state gets those 29 votes. Texas, another big state in the United States, has 39 votes. And Trump obviously won that one as well. Yeah, there's some close elections, and the last few elections have been really close as well. So yeah, so you can see Trump obviously won that. That's why he got the 38 votes from Texas. Trump, another one up here, he won by a huge margin. Trump got 70.4% of the votes in Wyoming. Same thing for Idaho. It's a pretty big margin. He won there too. Yeah, Joe Biden took California. He got those 55 votes. So these like last states here, Wisconsin, Michigan, Georgia, North Carolina are really going to determine who gets that 270. So the remaining votes are 10 for Wyoming, 16 for Michigan. Pennsylvania's got 20. It goes by population, how populated it is. North Carolina, you can see, is 15, and Georgia is 16. Alaska only has 3. Every vote counts, so. See if we can zoom. Oh, you could zoom in on New York even more. So you could see like by county, like who like really picked which party. Here we are, Oneida County. And it looks like Trump won our county. But Biden won the bigger cities, Syracuse, Rochester, not Buffalo. Albany's up in the air a little bit, but New York City, that's where the majority of the population is for New York State. So a lot of these smaller counties in the red, Trump won, but the populated counties, Rochester, Syracuse, Utica's up there, but that's a little outlier. Albany, New York, where the main population is, was won by Biden. So anyways, check that out. You guys should get more and more into that stuff. I voted yesterday. Hopefully when you're 18, you vote too. All right, so welcome back. Here we go. Let's just check it out. So daily agenda, welcome back. Our quote of the week, haven't seen you guys in 5 days, so I missed you guys. What happened? We had Halloween, we had some snow, we have the sun out. It's gonna be 70 degrees again this week, so take advantage of the weather that you have, because pretty soon, another couple of weeks, it's gonna just be cold, chilly. You'll be like locked up inside. So take advantage, go for a walk if you have time today. Quote of the week is from Albert Einstein. Education is not the facts, but the training of the mind to think. There you go. The daily agenda for Wednesday, November 4th, 2020 is a day 4. We're continuing on with unit number 3, the atom. We're going to talk about what an ion is, but before we do that, we're going to have a little bell ringer. It's not going to be graded, but a little bell ringer to identify protons, neutrons, electrons, all that stuff about the atom. We'll watch a YouTube video on what an ion is. We'll take some notes, review questions. There's an exit pass we'll be doing on Saturday. We will get into topic number 4, which is isotopes and atomic mass. It's a pretty easy topic. They're going to go pretty quick as well. Watch a YouTube video, notes, examples, exit pass. You know the routine. You can see the attachments below as well. Again, at any time you want to review what we went through in class because you missed something, you had to run to the bathroom, I am recording, so you can watch that obviously as well. So you can rewatch it if I went too fast. All right, please open up the due today. Actually, no, not the due today. The one thing above on the classroom stream, it says post a new assignment for identifying O. That's the one I want to do. So please click on it. I just posted it maybe 20 minutes ago. Not even. Click on that, and we're going to do this one again together just to make it go a little quicker. You definitely want a reference table out today, specifically a periodic table. I would definitely have like your hard copy that I sent home to you guys right by you as we do class for today. Spread on out, go to the kitchen table, find a spot on the floor. I don't care where you work, find your little zone, get into that groove. All right, so anyways, it says determine the following for O. So I want to know what this element is for O. I want to know the name of the element, atomic number, protons, neutrons, electrons, electron configuration, mass, nuclear charge, and the atomic charge. So I'm pulling out my reference table, my handy dandy reference table, your best friend in chemistry besides me. Pull that out, and you could open it as a PDF, or if you have the hard copy in front of you, awesome, you can use that too. So the first thing I want to do is identify what the symbol O is. What element is it? Please put it in the chat privately, or yeah, just put it in the chat privately, please. Please tell me what the element O is. Thanks, Alan. 2. Wait for 5 correct answers, then we move on forward. 3, thanks, Kim. 4, thanks, Micaiah. And Phil, thank you. So O is definitely oxygen. So O is right there, but if you zoom in on the reference table, the next page, if you don't know what the symbol is, you can look on the next page, page 1011, and gives you a lot of physical characteristics or physical properties. O is oxygen. So the name of the element is oxygen. So oxygen is the element we're analyzing. If you want to change your color, go for it. I don't care. The atomic number for oxygen is what? Please throw it. No, I don't need to do this. Oxygen's right here, and it says the atomic number is 8. It says it right there on the reference table. So 8 is the atomic number. It says it right there on page 1011. Actually, page 10. All right, more information, proton. So now that's all the information. I can look at page 10. Let's just check out the element. I'm gonna, hopefully I don't freak you guys out too much, but I'm gonna do a lot of this today. Scrolling and zooming in. Hopefully you can find where O is. You have your reference table in front of you. There's my O, right there. All right, so for oxygen, I want to know how many protons in there. Please put that number of protons in the chat privately. Oof, different answers there. So proton number is the exact same thing as the atomic number. So if you know the atomic number, which happens to be right there, the atomic number is the exact same thing as the proton number. Proton number equals the atomic number. So 8 is the number of protons. 8 protons. Next up, please figure out number of neutrons. Please put in the chat privately. Five answers. Yes, Michael. Yes, Tristan. No, Tristan, sorry. Alex, yes. Santino, no. Alan, yes. Joe, yes. All right, so where do neutrons come from? Neutrons come from the mass minus the proton number. So my mass is up here. If you don't know where your mass is, you can zoom on out. You can figure out all this information from the elemental box by looking at the key of carbon. So you have to memorize basically how to figure out number of neutrons. It's the mass minus the proton number. So you're taking 12 minus 6 for carbon. That would give you the mass, the number of neutrons for carbon. Same thing for oxygen. You're taking the whole number of the mass. Mass is 16 minus the proton number, the atomic number of 8, which would give you 8. How many electrons do we have there? Electrons says electron configuration. Yes, Nadal. Yes, Asim. Thank you, Joey. Yes. Okay, so that's 8. Number of electrons comes from electron configuration. If you add those two values together, you can figure out the number of electrons, or proton number equals the electron number. Electron configuration comes from the bottom left-hand corner. It says electron configuration on the little key, so that's 2-6. The mass comes from up here. The key says mass. You'll see that today in class. It is 15.9994 AMU. Atomic mass units. That's a unit on that one. What's the nuclear charge? You need 5 correct answers, and we'll go over it. Nuclear charge. That's Joe. Positive what? Tristan, yes. That's Nadal. Alex, that's the next one. Nuclear charge is the charge of the nucleus. So let's check that one out. So now I'm going to go to let me get rid of that thing over there. Now I'm going to go to this diagram over here. I'm going to make this diagram. I'm going to put this down below. That is my nucleus. Inside the nucleus is going to be the protons and the neutrons. Inside the nucleus, we have the protons. There's 8 protons. 8 protons. Make my font a little bit smaller. Nuclear charge, yep. So I'll make my font smaller so I can fit this all in there. Oops, too small, I guess. Or I can make my nucleus bigger. I don't care. I have 8 protons, 8 neutrons. Again, protons are positive. Proton, positive. I have 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. And I also have 8 neutrals, 8 negatives. 8 neutrals, not negative. Excuse me. Neutrons are neutral, so there's 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So if I analyze my positives and my zeros, the nuclear charge is going to be what's remaining, what's left over. Nuclear charge is the exact same thing as the number of protons. There's positive 8 plus 0. The overall charge is going to be, nuclear charge is going to be 8, positive 8. There's a nucleus. Yes, atomic mass we round up to 16. So if it is, so the rounding rule, if that number is greater than 5, then you round this on up. So 5, 6, 7, 8, that rounds on up. If that's 4, 3, 2, 1, you leave it alone. So 10th place is where you're going to round it. Figure out where you're rounding it to. Next up, the atomic charge. What's the The overall charge of the atom. Yes, Joseph, thank you. That's the overall charge of the atom. If you take account for protons, neutrons, and electrons, what's the overall charge? Yes, Alex. So nuclear charge is +8, yes, definitely. But now if I put these electrons in, let's do that. Let's throw these electrons in here. So I'm adding my rings of electrons. There's my nucleus. I'm adding the first ring. And that first ring is going to have 2 electrons on it. These little smiley faces are my electrons. So that first ring, I got that 2 from right there. This tells you there's 2 rings. There's one ring with 2 electrons. The second ring's going to have 6. So that first ring has 2 electrons. 1, 2. The second ring is going to have 6 electrons. So take 6 electrons, throw them on here. 1. I don't care where you put them, as long as you have 6 around it. 2. So if you don't understand this yet, you will understand the next few classes. I'm going to start the next few classes just like this. I'll have you construct, make an atom for each of the following. So different elements each day. So there should be 6 electrons around the second ring. Should look something similar to this. Doesn't have to look exactly like mine. Yours probably looks better. That's fine. I'm okay with that. So 2 electrons in the first ring, done, and 6 in the second one. 1, 2, 3, 4, 5, 6. So that would be a correct atom for oxygen. It's a Bohr ring for oxygen. Now my question is, what's the overall charge of this entire atom? We already went through the nuclear charge. We said the nuclear charge is +8. So protons, this part I wouldn't put down here. You said there's 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. Neutrons, there's 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And electrons, total electrons are negative. There are 8. 1, 2, 3, 4, 5, 6, 7, 8. So last thing up, you have protons, neutrons, electrons. You could cancel out the values. The positive cancels the negative. Cancels, 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 cancels. What's remaining? 0. So nothing left. The atomic charge of an atom, the charge of an atom is equal to 0. Why? Because the protons are equal to the electrons. What's going to happen today in class? The protons are not going to be equal to the electrons. We're going to talk about an ion where maybe there's more electrons or less than electrons than the protons. All right, so that's a review. You actually don't have to submit that to me. It's more of a review for you guys. In the future, you will have to submit it to me. I think I'll give you credit for that too. Does anybody have any questions on that? All right. You don't have to share it. It's more for your record. You can put it in your little Google Drive. Good to go. All right, so that's done. Next up, what are ions? Play a video, we'll get to our notes.
In this lesson, we will learn about what ions are and how they are formed. When an atom or loses electrons, they develop a charge. Recall that electrons are negatively charged, so the gain or loss of electrons will create a charge. These charged particles are called ions. When an atom loses electrons, they become positively charged. Positively charged ions are called cations. An easy way to remember this is to recall that cats have paws. When an atom gains electrons, they become negatively charged. Negatively charged ions are called anions. Let's look at sodium as an example. Its electronic structure is 2, 8, and 1. It has 1 electron in its valence or outermost shell. When sodium loses this valence electron, it becomes a positively charged sodium ion. This charge is written as a superscript when writing the symbol. When drawing the electronic structure, enclose it in square brackets and write the charge on the top right-hand corner. Now, let's look at oxygen as another example. Its electronic structure is 2 and 6. Therefore, there are 6 electrons in its valence shell. Oxygen gains 2 electrons to form a negatively charged oxide ion. Remember to include the charge when writing the symbol and when drawing the electronic structure. If we look at the electronic structure of these 2 ions, we will see that they have a complete outer shell. We will also see that they have the same electronic structure as that of a noble gas. The sodium ion and the oxide ion have the same electronic structure as the neon atom. How are you feeling about ions? Are you ready to form ions on your own? Let's try. Please pause the lesson and draw the electronic structure of a calcium ion and a chloride ion. The electronic structure of calcium is 2, 8, 8, 2. It loses 2 valence electrons to form a calcium 2+ ion. The electronic structure of chlorine is 2, 8, and 7. It gains an electron to form a chloride ion. These 2 ions have the same electronic structure as an argon atom. Did you get the structures right? And did you remember to specify the charges? What do sodium and magnesium have in common? They are both metals, and metals lose their valence electrons to form cations. Group 1 metals, such as sodium, have 1 valence electron, and they lose this electron to form ions with a +1 charge. Group 2 metals, such as magnesium, have 2 valence electrons, and they lose these electrons to form ions with a 2+ charge. Oxygen and fluorine are both nonmetals. Nonmetals tend to gain electrons to form anions. Oxygen is in group 6 and has 6 valence electrons. It gains 2 electrons to form an ion with a -2 charge. Fluorine is in group 7 and has 7 valence electrons. It gains 1 electron to form an ion with a -1 charge. Group 3 elements, such as aluminum, lose 3 electrons to form ions with a +3 charge. Group 5 elements, such as nitrogen, gain 3 electrons to form ions with a -3 charge. Group 4 elements, such as carbon, tend to form covalent compounds. Stay tuned. In conclusion, an ion is a charged particle formed from either the gain or loss of electrons. A positively charged ion is known as a cation, and a negatively charged ion is known as an anion. The ions formed have the same electronic structure as their nearest noble gas.
Okay, if you caught all that information from that video, you are in great shape for ions. You understand them. But now let's go through and actually put some notes together so we really understand it. So please open up your guided notes. It's Unit 3, the atom. Okay, Unit 3, the atom. Thought I had it open. Oh, there it is. Okay. All right, so a little snapshot of where we've been throughout the atom. We already went through the history of the atom. We talked about basically the Greeks. We talked about Dalton's atomic theory, talked about J.J. Thomson. Rutherford's gold foil experiment proved the existence of the nucleus. Niels Bohr, we just made one in the class, the Boehringer, and the wave mechanical model of the probability of finding an electron. Topic 2 was about subatomic particles, protons, neutrons, electrons. We broke this up. We identified different properties of the elemental box. We know a proton is positive, a neutron is neutral, electron is negative. The proton has the same mass as a neutron. Know that. The proton and neutron are inside the nucleus. Nucleons are protons and neutrons. And electrons, they just orbit around space. Hopefully you can make the connection between protons, electrons, atomic number, and nuclear charge. They're the same in an atom because an atom is neutral. Neutrons come from the mass number minus proton number. The mass number comes from proton plus your number of neutrons. And then we did standard notation as well. Moving on forward, this is where we left off with ions. So topic number 3 is going to be ions. I'm going to color these in just to say we went through them. Ions is going to be today, and then later today we're going through isotopes and atomic mass. All right, so at this point, we said protons and electrons are equal because they're atoms. Now it's going to get a little crazy because ions are involved, and something's going to lose or something's going to gain those electrons. So a neutral atom. So here we go. Let's fill in the blanks here. A neutral atom is everything we talked about previous to today's class. Hopefully you know the concepts of an atom. An atom is going to be, so an atom, I don't care if you change the color or font, I'm not going to today. An atom with the same number of protons, same number of protons and electrons. An atom. Atom is neutral. Why? Because the proton number is equal to the electron number. Those should both be lowercase letters. Proton number is equal to the electron number in an atom. Atom, proton, equal electrons. Notice in the situation over here to the right, there's no positive or negative charge here. If there's no positive or negative charge, then that is going to be an atom. Sometimes there'll be like a positive over here or maybe even a negative. That is not going to be an atom. That is going to be something called an ion. So proton number equals the electron number. That's an atom. Nothing crazy there. We already talked about that stuff previously in class. The first one up is going to be an ion. So two different types of ions. We have an anion, and we also have a cation. So anion's the first one. I'm going to underline that part too. But anyways, an anion An anion is going to be a negatively charged ion. So anion has that N there. I'm going to put a N there. It tells you it's going to be negative. I'm going to underline it too to show you like a little negative sign. Anion. An anion, what makes an atom negative? An atom that has gained one or more electrons. So what makes an atom negative? So protons are positive, neutrons neutral, electrons are negative. In order for an atom to become more negative, you have to take a negatively charged electron, grab it, and put it on the atom. So if I take a negative charged electron, pull it on me and put it on top, now I'm going to be more negative. If I take 1, I'd be -1. But if I take 2, I'd be -2 instead. If I took 3, I'd take more negatives and be -3. In this situation, the electrons are going to be greater than the proton number. So electrons are greater than the protons. Where did I get that symbol? It's just shift period. Shift period. And these are going to be called negative ions. It makes sense if you think about it. If something becomes negative, in order for an atom to become negative, they have to either gain protons, neutrons, or electrons. Think about the process. In order to be more negative, you have to take a negative electron and add it to it. So in the situation to the right, we have F19, to be called. The -1 indicates a negative charge with a magnitude of 1, a numerical value of 1. This would mean that the F gained 1 electron. So it took in 1 electron. So if it was F0, then protons and electrons are equal. Since it's F-, it took an electron and put it on top. That's going to be obviously a negative charge. Anion, negative. How is it negative? It gains electrons. So know anion, negative. It's negative. Questions on anion? All right, next one up is cation. So cation, this should be a T after, but I'm not going to put a T. Instead of the T, I'm just putting a plus sign because I think of the plus sign as a T, lowercase t. Cation. Cation is a name, and it has that plus sign there. So once negative, we know how it's negative by gaining electrons. How is something going to be positive? You have to take an electron off and say, get out of here, get that negativity out of my life. Take that electron off the atom, throw it away. If you take an electron away, you become more positive. So in a cation, an atom that has lost one or more electrons. An atom that has lost one or more electrons. In this situation, the protons are going to be greater than the electrons. There's more protons than electrons. So if I have more protons than electrons, I'm going to do a little example over here to the right. So let's just analyze lithium. Lithium has protons, which are going to be equal to three positive charges. And the electrons of lithium, atom, if we just analyze the atom first, the atom would have 3 negatives. In this situation, those 3 would cancel out. But if I have more protons than electrons, I'm not going to add another proton here because that's going to make it a different element. So if it went from 3 to 4, it's going to turn into beryllium. So we're not going to change the number of protons. Only thing you could change is the number of electrons. So if we lost this one electron, this electron says, see ya, I'm out of here. See ya, found someone new. What happens, the overall charge here in the situation, let's see, figure this out, getting better at this stuff. This would cancel, a positive one and a negative one cancels. What's left would be just that positive 1. So why is it positive? Because that one electron that was there said, see ya, I'm out of here. It's going to bond with something else. So what we're getting towards is going to be like chemical bonding. So hopefully that helped with that situation. Same thing with my Fs. If I have 9 positives, hopefully it's 9. And in the atom, if I had 9 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. Got one a little crazy there. Sometimes I get a little cray-cray going. All right, so this would be the atom. They would all cancel out. If it were an ion, I need a negative. So to make it an ion, I need 1 more negative. So that 1 more negative would be another electron coming on in. So if 1 more electron comes on in, 1 more electron, make that red. And then if we cancel them all out, we can see that cancels, 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 cancels. What's left over is 1 more electron. The electrons are negative. That's where that charge comes from in that situation as well. Hopefully those visuals helped you out a little bit. That's a cation. Cation positive. Why? Because it lost an electron. If I take an electron away, it becomes more positive. All right, let's check out some review questions. Let's go through these. I'm going to wait for 3 correct answers, and then we'll move on forward. Please privately message me, chat me. Once I get 5 correct answers, we'll go on to the next one. Number 1, when a neutral atom gains an electron, it becomes what? Number 1, when a neutral atom gains electron. You can use the notes above. Yeah, I got a lot of C's there already. Perfect. So C, neutral atom gains. If I gain an electron, it's become a negative anion. Yes, choice C is the best answer. I'm going to highlight it and then just put highlight it as well with a different color. I don't care. Negative anion. If something gains an electron, it's going to be an anion. Anions are negative. Good. When a neutral atom, number 2, when a neutral atom loses electron, please put the right answer. Oh, they're rolling in. Thank you. Positive cation. Nice. So if it loses an electron, loss of electron, it's a cation. It's going to be a positive. Number 3, what is the charge of magnesium ion that has lost 2 electrons? So magnesium loses 2 electrons. What's the charge going to be? Positive what, Kai? Negative. So if I take 2 electrons off me, 1, 2, I take 2 negative charges off me. The overall charge is now going to be positive something. It's going to be positive 2. Let's check that one out. Magnesium loses 2 electrons. So there's my magnesium. If I lose 2 electrons in the situation, that's my magnesium. I have 2, 8, 2. So I have 12 protons, I have 12 positives, and initially I have 12 negatives. If I lose 2 electrons, these 2 are now gone. Those guys are out of there now. So these guys no longer exist. What's the overall charge? So 2, 8, 2 gives you 10 negatives plus 12 positives. What's left is going to be that plus 2. So if I take 12 positives, I'm not going to write it out, and 10 negatives, what's remaining is going to be just that plus 2. So you can see the connection where these numbers are coming from a little bit. What's the charge of fluoride ion that has gained 1 electron? Take 1 negative charge, grab it, put it on. What's your charge? Yes, Tristan. Yes, Joe. Yes, Kai. It's 3. 2 more, please. Yes, Jordan. Ooh, Phil. Electrons are negative. If I get 1 negative electron, the overall charge would be -1. Close, Phil, though. Let's just check that one out. Fluoride is fluorine. Fluorine's all the way to the right, to the nonmetals. We'll get to this stuff. If I gained 1 more electron, it's going to be 2, 8, 7. No. If I gain 1 more, it's going to be 2, 8, 8. So in that situation, that -1, great, -1 would be the charge. If I gain 1 more, protons would be +9. Electrons initially are going to be -9. If I gain 1 more electron, 1 more negative, it'd be -1. So yeah, -1 was the best answer for that one. Number 5, the chemical symbol S-2 represents S-2. Check that out again, Joe. Think about the electrons. So we have, yeah, most people with the right answer. Minus sign, if you look at the minus sign above, negative sign is going to be an anion. That's the first part. So anion, it's got to be C or D. Now that -2 means you take 2 more negatives in. So you have to gain 2 more electrons. So in that situation, D is the best answer. An anion's negative. Why is it negative? Because it takes 2 more negative charges in. Anion, negative, gains 2 more electrons. You do the opposite of what this says. I'm not taking 2 electrons away, but rather I'm gaining 2 more electrons. Maybe that's another way to think about it. So trace D is the best answer for that. Number 6, the chemical symbol Fe+3 represents, let's put your answer. Yeah, a lot of A's popping through, so I'll put B. So again, do the opposite of what that says. I'm not adding 3 electrons, but I'm actually losing 3 electrons. Think about the process. Electrons are negative. Electrons are negative. If I take 3 negative charges and put them on top of you, you took 3 more in, you're more negative. But if you take 3 electrons and throw them away, you become more positive. So yeah, A is the best answer for that one. Number 7, give the correct chemical symbol for the ion form when O oxygen gains 2 electrons. Chemical symbol for the ion. So please, 5 correct answer. Yes, Leonardo, thank you. Yes, Kai. Superscript. Miss Tintin, Tristan, good. Oh, Jordan gains 2 electrons. Electrons are negative. You gain 2 more. A lot of you guys put the right answer, so it's going to be O, oxygen. And then up in the superscript, exponent is going to be, I'm going to hit control period minus 2. O minus 2. I guess one way you could check is look at the reference table, and O can potentially have a minus 2. So if it gains 2 more electrons, it'd be 2, 8, which would give you 10 electrons. Last one, get the correct symbol, chemical symbol for the ion when sodium loses 1 electron. Loses only 1, Tristan. Yes, Joseph. Yes. Jordan, yep. No, Jordan, the sign again. Think about it. You're losing something. Check out the notes again. Loses, loss of electron. It's got to be a positive. Okay, good. All right. So it's got to be that +1. So Na +1. Na, and it does the opposite of what you said. So +1, control period, +1. So that means I'm not adding an electron. I'm actually losing 1. Whatever it says there, it does the opposite. Again, check it out. You can look at the reference table and say, is it possible for that to happen? Yeah, 2, 8, 1. That +1 means I could lose that 1 electron from that shell. So it'd be now 2, 8 in that situation instead. All right, so that is an ion. We'll talk more about ions for electron configuration. Definitely know this chart inside and out. Anion, negative. I have negative charge. It means it gains electron. Cation, positive. It's going to be something that loses electrons. And the number indicates how many electrons you lost or gained. But we'll analyze more for electron configuration as well. All right, on to the next topic, which is going to be topic number 4. It's going to be isotopes. Easy topic. And for isotopes, I don't know if I have a video for this one. I forgot. Yeah, I'll start with a video. Quick little flick on isotopes.
All atoms of a particular element have the same atomic number. This means that they all have the same number of protons. But sometimes you can find heavy atoms of a particular element. These atoms have a higher mass number. The mass number is equal to the number of protons plus the number of neutrons. We can ignore the electrons as their mass is so tiny. If the number of protons always stays the same in a particular element, and we are ignoring the mass of electrons, it must mean the number of neutrons is causing the difference in mass. Atoms of the same element with a different mass number are known as isotopes. They are defined as atoms of an element which have the same number of protons but a different number of neutrons. If we look at carbon and nitrogen, are they isotopes? They have different mass numbers, but they also have a different number of protons. Therefore, they are not isotopes. They are completely different elements. Different isotopes of elements do not have separate positions on the periodic table. They occupy the same spot because they have the same number of protons. What about carbon-12 and carbon-14? Both carbon-12 and carbon-14 have the same atomic number, which means they have the same number of protons, but they have different masses. Carbon-12 has a mass of 12 and 6 protons. Remember, mass number equals protons plus neutrons. So we can rearrange this formula to give us neutrons equals mass number minus protons. 12 minus 6 equals 6. Therefore, it has 6 neutrons. Carbon-14 has a mass of 14, but it still only has 6 protons. Mass number equals protons plus neutrons. Rearrange. Neutrons equals mass number minus protons. 14 minus 6 equals 8. Therefore, carbon-14 has 8 neutrons. Carbon-12 and carbon-14 are not the only examples of isotopes. There are many more, such as hydrogen, deuterium, tritium, and chlorine-35 and chlorine-37. Isotopes only differ in their number of neutrons and their mass. Their chemical properties are exactly the same because neutrons have no effect on an element's chemical behavior. This is controlled by electrons, which we will discuss in another video. So isotopes are atoms of the same element with the same number of protons but a different number of neutrons. They have different masses, but their chemical properties are exactly the same.
Okay, isotope. Easy term. Definitely make a flashcard for isotope. This is going to be tested somewhere on the Regents, benchmarks. Every year they ask questions about isotope. Isotope, same element, different mass number. Isotope, same number of proton, different number of neutrons. There's several different variations for defining what isotope is. So you have to know what these terms mean, protons, neutrons, electrons, and then an isotope definition will be very easy to define. An isotope. Here you go, atoms of the same element. One definition could be atoms of the same element with different mass numbers. That's one definition. An isotope, another definition you could say. Same atomic number, but different mass numbers. There's another definition. Another definition, same number of protons, a different number of neutrons. There's 3 different definitions for what isotope is. They're all the same thing though. Isotope, atom of the same element, but different mass number. So it has to be the same element. Think about that. If the element's the same, if something's the same element, the atomic number has to be the same, the number of protons have to be the same, the symbol has to be the same. So the first phrase in all 3 of those is going to be the exact same thing. Same element, so proton number is the same, the atomic number is the same, but the difference between an isotope is the masses are going to be different, or the number of neutrons, they could differ. So all 3 of those definitions are basically the same thing, but you're just relying on maybe mass number versus neutron number. Isotope, same element, different number of neutrons. Same element, different mass. You should be aware of all of those definitions. You should know what they all mean. There's 2 examples here to help you identify what isotope is. Example number 1, we have isotopes of carbon are going to be carbon 12, carbon 13, carbon 14. These are all isotopes. I have 3 different isotopes of carbon. So carbon 12, carbon 13, carbon 14. We should know after the symbol is going to be a mass. So after the symbol, that's going to be the mass. It's not the proton number, it's not the neutron, it's not the electron. That's the mass of the atom. So carbon has a mass at 12, 13, 14. If you didn't know it from there, we should know in standard notation, the mass is upstairs, proton number is on the bottom, that's the symbol. So the proton number in all these, we have 6, 6, 6. The proton number or the atomic number identifies which element you're dealing with. So if I say, hey, check out element number 6 in the reference table, you're going to check out element number 6 and say, oh, number 6 is going to be carbon. So if I say 6, it's always going to be carbon. It's not going to be anything else. Element number 5 is always going to be boron. Element 7 is nitrogen. Element number 6 is carbon. Element number 6 has 6 protons in each one of them. There is no charge up here. So every one of these, it's not positive, it's not negative, it's a 0. So every one of these atoms or isotopes is an atom, which means the proton number equals the electron number. So since there's nothing up here at the top right corner, this charge of the entire atom would be equal to 0. So that means the proton number equals the electron number. So in this situation, we have 6 electrons. This one has 6 electrons. This one has 6 electrons. This is where it starts to differ. Number of neutrons. How do we get neutrons? You take your mass and you subtract it by your proton number. So that's my mass. And you subtract it by the atomic number or the proton number, same exact thing. So you subtract those two values and we get a value of first one, 6. 12 minus 6, 6. The second isotope, you have 13 minus 6, 7. Last one, 14 minus 6 gives you 8. And isotope is going to be the same proton number, different number of neutrons. Those are isotopes of carbon. An isotope is going to be the same atomic number, different masses. Same symbol, same element, different mass. Same element, different number of neutrons. So definitely, isotope refers to number of neutrons and mass being different with the same element. Pretty easy. Anybody have questions on that first example? Anybody need more time? Cool. All right, scrolling on down, second example. We have the second example of isotopes. Isotopes of uranium, U-238 and U-240. So again, symbol, mass, symbol, mass. So in this situation, you probably want to use your reference table because there's no proton number given to you. It's a different notation, isotopic notation. Standard notation, isotopic notation. And this situation, you know, protons, neutrons, or electrons. So let's pull out the reference table. Let's find out where the heck this uranium is. So analyzing uranium. You could scroll through the periodic table and look for that U. Or you could go on the next page and solve and look for uranium here as well. So you scroll through, look for a U or uranium. You're gonna spend some time going through it and you say, hey, it's actually not there, Mr. Brown. What are you talking about? Yeah, but you will know what uranium is because we're gonna have a whole little topic devoted to uranium. We're gonna talk about nuclear chemistry. Uranium is actually element number 92. Not all the elements are given to you, so let's just point that out right now so we see it. It says elements 58 through 71 have been omitted. So those elements, 58 through 71, are not going to be on the reference table for their physical properties. So most of the time, you're not going to know much about those elements, but uranium is definitely an outlier where you'll have to know about it. Be aware of what it is at least. Oh, no. Sorry. All right, so there's uranium. I'm going to zoom in on uranium and figure out some properties of that too. So don't get discouraged by each of these boxes. If you know how to identify one of them, you know how to identify all of them. So you can check out uranium and say, oh, that is my mass. That's my atomic number. And then these are my oxidation states, which we'll slowly get into. But anyways, uranium, we have protons, which is equal to 92. Yeah, thanks, Tristan. 92. This proton number for uranium is exactly the same thing. 92. How many electrons I have for uranium atom? Please throw in the chat, or you can unmute yourself. I want to say hi, Mr. Brown. How was your Halloween? That was good. Thank you, Joseph. 92. So electrons are equal to 92 as well. There's no positive or negative charge. Hey, how you doing? There's 92 on that one as well.
Hi, Mr. Brown. How was your Halloween?
Oh, thank you very much for asking. I appreciate it. Mine was great. How about you? I was waiting for you to ask.
Pretty boring, not gonna lie.
Yeah. Well, since you asked, I might as well just show you what the family was. So this is Google Photos. If I take a picture on my phone, I can automatically upload it to my, basically here. So we're in Ozland. And my little guy, he was the lion. Wizard of Oz. There's a scarecrow. There's my little Dorothy. There's the evil witch. My wife. She wasn't that evil. And I was the Tin Man. And SN Man. SN's Tin. There's Yellow Brick Road. It was a good time. But whatever. And then we painted some turkeys. It was a good time. So she's in kindergarten, but she doesn't get much at the special. So I try to be the art teacher and all that stuff too. Oh, this too. The snow day. Snow day.
Woo! Nice.
Now it's gonna be like 70 degrees out there. So thanks for asking, Tristan. That's it. Oh, my son has birthday too.
No problem.
So my son has a little birthday. He's 4 now. There's my boo. That's my boo right there. And my little guy. There's a construction party. But due to COVID, we only had my parents and her parents over. My wife's family and my family. So, well, thanks for asking, Tristan. All right, so back to neutrons. Hopefully you guys had a good 5 days off too. Does anybody want to share anything with me or your classmates? Google Photos, if it's appropriate. All right, whatever. If you want me to know more about you, we can hang out after and talk on Zoom. Or if you need help, I'll stay after and obviously go through more questions with you too to help you out. I did that a few times in some exit passes I went through with some students. Mainly did a lot of the questions together. So, all right, so neutrons of uranium-238. Just put in the chat or unmute yourself if you'd like. It's mass minus proton number, which equals, thank you, Joseph, 146. So again, what Joseph did, Tristan did, they took the mass and subtracted by 92, we got 146. If you're doing neutrons for the other one, take the mass minus proton, so 240 minus 92, yeah, 148, thanks Jordan, 148. And isotope is same number of protons, different number of neutrons. An isotope is the same elements, but a different mass. Know that definition. Be aware what that is. Questions on isotope? All right, let's do these questions. 2 different isotopes of the same element must contain the same number of, I'll wait for 5 correct answers, privately message to me. Same number of, good, protons, same number of protons. Protons, best answer. Number 2, 2 different isotopes of the same element must contain a different number of, yes, Kai, yes, Tristan, Michael, thank you, neutrons. Neutrons must be different. Just a term, isotope. Definitely know that one. You should know what an ion is. There's some I terms like 7 I terms you should know by the end of the year. You should know what ideal gas is, which is a high temp, low pressure. You should know what an ion is, an atom with a charge. Why is it charged? Because it lost or gained electrons. In an isotope, you should know is going to be the same element, but a different number of neutrons. We'll have some more too. Isotope of given element have so tell you there. Same atomic number, different mass. Good. That's an isotope. There are some questions on the exit pass on an isotope. Okay, it's easy. Isotope, pretty easy. It's just a definition. You guys know the basics of it. Not too tricky. The last thing for today's class is calculating the atomic mass. So the mass comes from that number, like up there. We want to know where it comes from. We know the mass number comes from the protons plus neutrons of an atom. But the atomic mass is not going to be like a whole number. It's expressed a little further out in detail. That's the next thing we're going to be figuring out where that comes from. So calculating the atomic mass. Here's some notes on it, but after we do some examples, you'll understand how this as well. The atomic mass is the weighted average of an element's naturally occurring isotopes. So for carbon, this had 3 naturally occurring isotopes. If I figured out the atomic mass of it, you have to take the mass of all 3 of these and multiply it by the percentage of each of these. So basically, like these 3 would jump on a scale, and then you would average it all out. Similar to that concept, but you also have to take into account the percentage of abundance there is too. Sounds complicated, but it's not that bad. So the percent abundance of an isotope in decimal form times the mass of the isotope plus the percent abundance of the isotope times the mass of isotope number 2. You do the same thing for number 3, then you add them all together. That's where the atomic mass comes from. Let's check out this example, and we'll do a couple. Example number 1, the exact mass of each isotope is given to you. Chlorine has 2 naturally occurring isotopes. Cl35 has a mass of 34.96889. I'll highlight that one color. Cl37 has an isotopic mass of 36.9659. I'll highlight that another color. In the atmosphere, 32.51% is going to be chlorine 37. So chlorine 37 is green. The percent of that is going to be 32.51. And 67.49% is chlorine 35. So that's my teal that I highlighted. So again, like everything else we do, figure out what the heck they're given to you. You know what isotopes are. There's a mass, another mass, and then 2 different percentages. They want us to know what's the atomic mass of this chlorine. How the heck do we calculate mass? You take each isotope. So there's a mass. You put it right up here as well. So the first thing you have, and put this in a different color font too. So it's going to be the atomic mass times percent as a decimal. So that's what those numbers represent below. So this is going to be the atomic mass of chlorine 35, which is 34.9689. Those came from above. So 34.9689 is right there. The percentage is going to be converted to a decimal. How do you convert a percent to a decimal? You divide by 100, or you move that decimal 2 spots over to the left. So in this situation, if I took that decimal of 67.49, if I move that decimal over 2 humps over to the left, that's going to convert it back to a decimal. So percent back to a decimal. It was there, it moved over 2 spots over to the left. That's how you convert. It has to be converted to a decimal. I guess that's the hardest thing for students to remember to do. The next one. So we'll definitely do another example, so don't really stress about this too much. This is going to be the green font, the green highlighter. We have the mass, which is 36.959, times the percent of the decimal, which is going to be 32.51. How do we convert that to a decimal? You took that decimal and divided by 100, or moved it 2 spots over to the left. We get 0.3251. The last thing you have to do once you multiply them is add them both together, and then you're going to get an atomic mass of 35.6181. There's a quick little example, but let's do one. So that came from that. Hopefully you could follow my color coding scheme here. I'm a little crazy with my color coding, but I think that helps. All right, so your atomic mass would be 35.6181. The units on that would be AMU. Or you could say units, which would be AMU, or atomic mass units. There's 3 different ones you could put for the units on that. Let's do one actually together on our own. So there's one example. If you could follow that, you're good. Second example, you could check that out if you want to. I'm going to do hopefully at least one or two of these examples the rest of the class. So practice question number 1. The element boron occurs in nature as 2 isotopes. So there's 2 isotopes for boron. In the space below, calculate the average atomic mass for boron. So one other thing here, I'm going to straighten this out. It didn't really transfer the right way. So I'm just going to delete some stuff here to make it line up appropriately. That's why my tab on top, my margin on top, has to be pulled over to the right more. So that little margin, grab it and pull it on over to the end of that little text box. So what happened there is like it kind of stopped the page there. That's why I went to the next one. So I pull that margin on over, we'll be on the same level. Yes, elevating our game each day, or knowledge. All right, isotopes. So you have isotopes, you have a mass, you have percent abundance. You have boron 10, which mass is going to be 10.031 AMU. We have 19.9%, so that's going to be the same isotope. Those are all related. Boron 11 has a real mass in nature of 11.0093. And percent of 80%, 80.1%. So in this situation, think about this concept. Most of the boron is 80%. 80% of the boron is going to be 11.0, whatever. And only 20% is going to be that 10 mark. So hopefully you could analyze this and say, oh, most of it's going to be 11. So when I calculate it, my overall mass should be closer to 11. Let's see if it works out here. So again, situation, I'm not going to add a new drawing here. I'm just going to copy it on down here. So the calculation is going to be the mass. So here's my work. So it's going to be the mass times percent is a decimal, plus, I'll show you a little different format, plus the mass of the second isotope times the percent as a decimal. And this is going to equal the overall mass in the situation. So the setup that I had the first time was exactly the same thing, but it's just in a different arrangement. Sometimes in the Regents they're going to ask for it. Show a correct numerical setup for calculating atomic mass. This would work out here. So the first half is going to be my boron 10. The second half is going to be my boron 11. So I'm going to copy and paste this. I'm going to copy it, Control C, and then press Enter and put the same thing on the bottom so I don't have to highlight again. Control V means to paste it in there again. And now I'm just going to plug in my values. So the mass for the first isotope is going to be 10.0130. This is the kind of stuff I wish I had this paper for. What are you going to do? Life goes on. Now I have to convert this percent to a decimal. So this one right here, I have to convert my percent to a decimal. How do I do that? I have to divide by 100 or move the decimal 2 spots over to the left. So I take that decimal, I move it there. Now I can figure out my percent. It's going to be 0.199. 0.199. The next one, the mass is going to be 11.0093, boron 11. That percent is a decimal is going to be divided by 100, 1, 2. So that one is going to be 0.801. The last thing you have to do is obviously calculate it. When you multiply 10.0130 times 0.199, I got an answer of 1.992587. Hopefully somebody else got that. I'll do it again just to make sure. When you multiply the second one, take 11.0093 times 0.801, I got 8.8184493. The last step you have to do is add them both together. And someone please let me know what you get when you solve for that. Thanks, Joseph. Yep. Yeah, okay, looking good. Thanks, Jordan. So you add them both together, you got 10.8110363. Units would be AMU. That's the one I'm going to use, not AMU. AMU, atomic mass units. That would be the correct unit for that. So there's a second example. Like I said, initially, if we went through and checked it all out, I initially said 80% is going to be boron 11. So most of it's going to be boron 11. 20% is only going to be boron 10. So this answer should be closer to boron 11 than 10. So that makes sense. So it's not a 50-50 blend, so it's not going to be the middle. Most of it's going to be boron 11. One way to check out your work here is take that number that you just calculated for the atomic mass, and that atomic mass will be very close to the reference table. So find boron in the reference table. There it is. Boron's element number 5. I don't know if you guys have had access to this CAMI. The school is trying to get access to this as well. Another note, if you need immunization shots, you only have like a couple more days to get it in. If you're lacking the immunization shots, you probably know if I'm talking to you. If you don't take it or don't get the immunization shots, New York State says you're no longer allowed to register for this class or to take the class. So I actually don't think any of you guys are in that situation, but if your friends are, let them know. All right, so one way to check it out is if you look at the reference table, hey, go for it, go to the bathroom, I'm not gonna hold you back. Check out your reference table. That mass number should be pretty darn close to the mass number that you just calculated. So there's a mass number, 10.81. 10.81 is pretty darn close. So when you calculate it, you should get a number close to that value in the reference table. If you got a value of 12, 13, 9, you may want to check out your math again. So that's another key where you can find that value. Let's go through the last example and then we're done. Good pacing. All right, so the next example, here we go. Practice question number 2. The element hydrogen occurs in nature as 3 isotopes. So H has 3 isotopes. In the space below, calculate the average atomic mass for hydrogen. Back to number 3. Which one, number 3? This one? Sorry, guys. I'm not just losing my mind. I got private messages here. So hopefully that's the one you need. If not, I'll go back after. Yeah. All right, so we have elements hydrogen occur in nature as 3 isotopes. In this space below, calculate the average atomic mass for hydrogen. All right, so H, this is standard notation. We have H has a mass of 1, H has a mass of 2, H has a mass of 3. We have protium, which means there's 1 proton. Deuterium, another isotope for it, which means it has a mass of 2. And tritium has a mass of 3. Tricycle has 3 wheels. Tritium has a mass of 3. The percent abundance, 99.0% is going to be hydrogen 1. 0.6% is hydrogen 2. 0.4% is going to be hydrogen 3. So you're smart. You figure this out. Most of the hydrogen, 99%, is going to be hydrogen 1. Your answer should be pretty darn close to the 1. This other makeup is so small, it's not going to really be a big factor in the mass. So here we go. Let's figure out this last one. I guess I'll copy this right here. No, I'll just rewrite it again. So the setup is going to be, again, it's going to be the mass times percent as a decimal plus the mass times percent as a decimal. And we have a third isotope this time, so we're going to take that third one and we're going to factor that in too. Mass times percent as a decimal. We're going to multiply them, add them all together. I guess I'll color code these as well. And I want you to take 5 minutes to go through this and try to get the answer instead of me doing it by myself. So please try to solve for this. Once you come up with an answer, please throw it in the chat. Yeah, that was quick. That highlight over here. What answers at me? That's what's off on that C. That's Michael. Better. Interesting. Good. All right, so that was 5 minutes, or close to 5 minutes. Here's my work on that. Hopefully you could follow my work as I went through it. So mass 10% decimal. Mass percent decimal. I had to move it 2 spots over to the left, we got 0.99. Mass, 10% of the decimal, plus the mass, 2, times percent of the decimal, plus the mass times percent of the decimal. Mass, percent of the decimal. Yes, John. So you take those 3 things, multiply them, I got 0.99 plus 0.012 plus 0.012 equals a mass of 1.014. Units are AMU. Please don't forget the units there. Yep. So 1.014. See, I'm not sure. Maybe didn't divide by 100. So that's the answer for that atomic mass. There's your answer. Boom. That is how you calculate atomic mass. Be aware of that as well. All right, last thing for class is just fill this one out, and if anybody wants to go through some questions for homework, I'd be more than happy to do that. To wrap it up. The mass number, so the difference between a mass number and atomic mass. The mass number is the mass of one isotope. Mass of one isotope. One isotope. So only one of a given element. Isotope. And the atomic mass is going to be the average mass. So it's all of them. That's why there's like a number of the hundreds place or thousands place on the reference table. The average mass of all of the isotopes. All the isotopes in the situation. So mass number comes from protons plus neutrons of one element. The average mass is going to be all the isotopes, the naturally occurring isotopes in nature, if you average them all out and get that value. One last thing, I forgot to check this out. You can check this number out with the reference table for hydrogen. You can pull up hydrogen and say, oh, is that number close? Find H. All the way to the left top. And H is right there. It's 1.00794. Close. Could be closer, but that's close. So 1.014 looks like a solid answer for that one too. All right, guys, on that note, that's it for today's class. If you want to hang out, I'll do some exit pass questions. You can do topic 1, topic 2, topic 3, and topic 4 should be completed for the exit passes by Saturday. So again, you should be able to do ions and mass for homework. All right, thanks, guys. I had fun too. Appreciate it, guys. Have a great day. Go for a walk. Have a good one, guys. See you later. If anybody needs help, ask for help. I'm free the rest of the day.
Have a good day.
All right, you too. We'll see you later. Thank you. You too. Good time. See you in chemistry class.
Mr. Brown,
Yes, Jordan.
there's an assignment due today,
Let's
and
check it
it's
out.
to identifying carbon.
Okay, I'm gonna get rid of that right now. Maybe, I'll sign that next time.
Okay, I didn't know if we were supposed to do that or not.
Get rid of that. So shouldn't be there anymore. Thanks for letting me know.
Okay,
All right.
thank you.
Yeah,
Have a
take
nice
care.
day.
You as well. See you later.